All right, the next part of this unit is a little bit tricky to follow through and to understand. So we're going to start very simple. I want to introduce the idea of an absolute value equation in inequality. And you've learned about absolute values before, but probably not in the context of any kind of an equation. So before we really get into these, it's actually important to have a sense of what it means, what an absolute value actually means. I mean, you all know that if the negative, or we have the absolute value of -5, then that's equal to 5. And if the absolute value of +5, then that's also equal to 5. What it basically means is that taking the absolute value of a number gets rid of the negative sign. But you might not understand why that's the case. And it's not as simple, the absolute value is not just as simple as get rid of a negative. It's not a negative disposing machine, like a negative disposal or something. The absolute value actually has a really important geometric definition. When we say the absolute value of -5, the absolute value, and make a note of this on your notes there, the absolute value is a distance from 0. When I say the absolute value of -5, I'm asking how far is -5 from 0? On a number line, if I graph a number line, and I have 0 in the middle, and I have -5 over there, the absolute value is that distance. And distances are always positive. You're not going to look at a yardstick and see negative numbers on it. A distance is always positive. It doesn't matter which direction you're measuring it from, a distance is always positive. And it doesn't matter, this is what happens then. It doesn't matter if we're talking about -5 or +5, it's a distance of 5 units, 5 inches, 5 yards, whatever the actual units of measure are here. It's always 5. It doesn't matter if we're to the left or to the right. So an absolute value is a distance. That's the important piece here. That's what you really need to keep in mind when we're trying to solve an absolute value equation. So keep this in mind. Keep this picture in mind when we go and talk about these questions here. I want to rewrite these using inequality notation where applicable, because only 1 or 2 of these are actually inequalities, and then graph the solution set. So we'll deal with the first one here first. I'm saying that the absolute value of x is equal to 3. That means that x, whatever it is 3 units away from 0. So if I graph a number line, and again I have 0 in the middle, what I'm saying is that x is something that's 3 units away from 0. And this is the important piece. It could be to the right or it could be to the left, because both of those distances are positive. This doesn't specify that it's the right distance or the left distance. It's just asking what values of x are 3 units away. You go to the right, you go to the left. 3 units, what are you going to find? Well, over here, you're going to find 3. And over here, you're going to find -3. Which means there's 2 answers to this. There's 2 values for x. It could be that x is equal to 3, or it could be that x is equal to -3. There's 2 answers. And almost all the time, there will be 2 answers. If we have an absolute value equation like this, or inequality, as we'll see in a little bit, there's almost always going to be 2 pieces to it. And it's this geometric idea, this distance that we're talking about, that's the really important piece of this. And it's also how we understand these inequalities. If we have that the absolute value of x is less than 3, well, it means that whatever value of x is less than 3 units away from 0. So what's a number that's less than 3, that's closer to 0 than 3? Well, 1 would work. So would 2. And so would any decimal, 1.3, 2.9, any other 0.1, anything. Anything in that area, and anything over here too. Anything over here as well. So what we're saying here is that, well, x can't be exactly -3 because we're saying that the absolute value of x is less than 3, We're saying it's less than 3 units away. So I can't have it actually at negative 3, and I can't have it actually at positive 3, but it could be anything in between. This is the picture that I get when I think of this. And the corresponding inequality then would be negative 3 is less than x, and then in turn less than positive 3. In general, any absolute value equation or inequality, if you see absolute value is less than, you're going straight to something like this. That's the general rule. This is true for any, whatever x is, even if x is not just a letter, if it's an expression, 2x plus 7. The absolute value of 2x plus 7 is less than 3. We're ultimately going to get an answer like this. So that's the idea. We'll see in the next video how to actually solve equations or inequalities like this. But this is what I'm saying here. Here I'm saying that x is less than 3 units from 0. Here I'm saying that x is exactly 3 units from 0. Which means that over here, where I have x is greater than or equal to 3, then that is my way of saying that x is, well, more than, x is exactly or farther than, we'll say, x is exactly or farther than 3 units from 0. So to make my number line then, I'm going to use the space down here. I have 0 in the middle, I have 3 over there, I have negative 3 over there. What I'm saying is that x is more than or exactly, so it could be, I'll do this in red, could be at exactly 3, that's okay. Could be at exactly negative 3, that's okay. But it would then otherwise have to be farther than 3 units away. So I can't be at negative 2 or negative 1 or positive 1 or positive 2. I have to be beyond the negative 3, so someplace anywhere off to the left here. Or beyond the positive 3, so someplace anywhere off to the right here. And so again, my corresponding inequality statement is going to be x is less than negative 3, or, because that's the pattern that this shape shows, x is greater than positive 3. That would be the way that I could rewrite this. Less than or equal to, greater than or equal to, because that's a greater than or equal to sign. So that's the idea. X, the absolute value of x is greater than or equal to 3 doesn't just mean that x is greater than or equal to 3. Just like the absolute value of x is less than 3 doesn't only mean that x is less than 3. Or that the absolute value of x equals 3 does not just mean that x is equal to 3. We also have the negatives in there as well. So keep that in mind. That's the trick for these absolute value inequalities. You're always going to end up with 2 pieces. That's going to be your step. At some point you're going to break it up into 2 things. So we'll see some practice of that in the next video.